Okay, one of the more advanced rules that we're going to deal with this year is the product rule for derivatives. And this is the derivative of functions that are products. So for example, we use this when we have a function that is multiplied by another function. So f of x times g of x. So if I have some h of x, that is the derivative. If I want to find the derivative of this, knowing that it's made up of two other functions, that's going to be when I use it. So for example, x times sine of x. This is a function of x and a function sine of x, and they're multiplied together. Or x e to the x. It's a function x e to the x. Or e to the x sine of x. Technically also x times x, you could use the product rule, but we could also just rewrite this as x squared and use the power rule. But this is when you're going to use it, is anytime you can write it as a function times another function, we can use the product rule. And the product rule is that the derivative of f of x times g of x is equal to the derivative of f of x times g of x, not the derivative, just g of x, plus the derivative of g of x times f of x. And you can write this all sorts of ways. You can switch whether f prime comes first or g prime comes first. You can switch whether g comes before f prime, right? All those commutative properties. But the key is it's the derivative of one times the not derivative plus the derivative of the other times not the derivative. And this is your product rule. That's what you need to know, this right here, this rule. In the next slide, I'm going to show you the proof of this, just so you see where it comes from. You don't need to know this. You don't necessarily even need to write it down. I just want you to track with it and see if it makes sense to you. So for the product rule, and in complete honesty here, I don't have this memorized, but I want to walk you through it to make sure you understand it. So we're going to start with our definition. So the limit as delta x approaches 0 of f of x whoops, I need to write this differently. F of x plus delta x times g of x plus delta x minus f of x times g of x all over delta x. And so in this case, you can see that we've got the original form, which is the function plus delta x, x plus delta x minus just the function. And so what we're going to end up needing to do here is some kind of tricky, clever math rearranging that, again, is just because it's going to make things simplify. So what I'm going to do is in the numerator, I'm going to add and subtract this right here, f of x, g of x plus delta x. And again, because we'll see why it cleans things up. So f of x plus delta x times g of x plus delta x plus f of x times g of x plus delta x minus f of x times g of x plus delta x minus f of x times g of x. So again, this right here is just adding and subtracting the same term, so it can cancel out and be equal to 0, or we can leave it in here, and then we will rearrange and do some factoring. And so we want to factor out a g of x plus delta x from a couple terms. F of x plus delta x minus f of x x. And we'll also factor out an f of x from a couple terms. Again, why am I doing this? Because it's a clever math thing that's going to simplify down nicely later. So I'll mark these for you here just so you can see where they match up. The g of x terms, that's going to be this one, and f of x, this one. The f of x terms are going to be this one and this one. Like so. Yes. Or actually, sorry, those are backwards. These two need to switch. That one and this one. And that way you can kind of see how they match up, and then this is still all over delta x. Now if we look at this, right in here and right in here, this starts looking like our original derivative definitions. So if we do this, limit as delta x approaches 0, I'm going to write these as two separate limits. I'm going to get g of x plus delta x times f of x plus delta x minus f of x over delta x plus the limit as delta x approaches 0 of g of x, sorry, it's getting a little sloppy there, g of x plus delta x minus g of x over delta x times an f of x out front. So now this, I know when I take the limit of this as delta x approaches 0, I'm going to get f prime of x. And I know when I take the derivative of this as delta x approaches 0, I'm going to get g prime of x. The limit as delta x approaches 0 of f of x is just f of x. There's a plus in the middle. And then as delta x approaches 0, this becomes just g of x. And you'll notice this right here is just a rearrangement of that product rule. So this is proof of the product rule, and we'll show a couple quick examples here. So the example f of x of cosine of x times e to the x. This is our f of x. This is our g of x. And so our derivative, well, I'm just going to rename this h so it's nice and easy to see. H prime of x is equal to f prime of x, g of x plus g prime of x, f of x, or in other words, it will be the derivative of cosine is negative sine of x, e to the x plus e to the x cosine of x. And that's our derivative. Again, just finding the derivative of each of the pieces, multiplying and adding on through. Next, g of x equals ln of x times 1 over x. This one involves a little bit of clever math that we're going to have to do. So it's ln of x times x to the negative 1. And we can do that because, again, this is just a function, and this is another function, and we know how to work with both of them. I'll call this h now. So it's going to be f prime of x, h of x plus h prime of x, f of x. Derivative of ln of x is 1 over x, and then ln of x, or h of x is still 1 over x, or x to the negative first. The derivative of h to the negative 1 is going to be negative 1 times x to the negative 2 times ln of x. And so if I just clean this up a little bit, I'll get 1 over x squared minus ln of x over x squared. And again, it's just applying all of the rules that we learned so far.